Hello, this is synapses of motion in a straight line. This is for Karnataka CET and Comet K. Okay. Now, first topic, speed. Speed is distance traveled by time taken. Distance traveled by time taken. SI unit is meter per second. Dimensional formula is LT minus 1. L is length for meter. S is second, time, therefore T minus 1. And speed is a scalar quantity. There is no direction for speed. So under this, uniform speed is nothing but equal distances in equal intervals of time. If a body covers say 5 meter, 5 meter, 5 meter equal distances in 1 second, equal intervals of time, then speed is said to be uniform. Okay. Second, non-uniform speed. So we can understand this in two ways. We can define this in two ways. If a body covers equal distances in unequal intervals of time, suppose 5 meter, 5 meter, 5 meter, this 5 meter is covered in 1 second, this 5 meter in 2 seconds, this 5 meter is 0.5 second, etc. Then this is said to be non-uniform speed. Then the other way of defining non-uniform speed, if a body covers unequal distances in equal intervals of time, 1 second 5 meter, next 1 second 1 meter, next 1 second 20 meter, here also the ratios are different, therefore it is non-uniform speed. Third is average speed. Average speed is denoted by V average, V bar or V average. Usually this bracket is used to represent average value, and this average speed is total distance traveled by total time taken. So this is how average speed is defined. Okay. Now, as an example, a car covers first half of the distance between two places at 40 km per hour and the rest with 60 km per hour. The average speed in kilometer per hour, kmph. Okay. So these are the options. According to the definition, average speed is total distance traveled by total time taken. Total distance traveled by total time taken. Understand this problem through this diagram. First half of the distance, let it be x, and the rest is also x. This distance is covered with 40 km per hour and the rest is with 60 km per hour. So total distance means x plus x, total time taken, speed equal to distance by time equal to distance by speed. So total time taken is x by 40 plus x by 60. X by 40 is time taken to cover this, plus x by 60 is time taken to cover the rest. Therefore numerator is 2x, denominator common factor is x by 20, 1 by 2 plus 1 by 3 equal to x get cancels, 20 goes to numerator, 220 by 1 by 2 plus 1 by 3 is 5 by 6. 5, 4, 6 goes to numerator, 6 into 4 into 2, 48 km per hour. So answer is 48. Now average speed of these two is not 40 plus 60 by 2, which is equal to 50. Okay, so this is the common mistake. This is the answer. Also observe one more thing. Distance traveled with speed 40, next distance traveled with speed 60. Our answer is 48 km per hour. This 48, this average speed cannot be less than 40. So average speed cannot be less than 40. Average speed cannot be greater than 60. It should not exceed 60. And this average speed is even not equal to 40 plus 60 by 2, that is 50. Okay. So these three values are not true. Next, equations of motion. Equations of motion. It is for accelerated motion. Okay. Accelerated motion. Acceleration, that is uniform acceleration. First is v equal to u plus at. Velocity, final velocity, initial velocity, these are vectors. Second equation, v square equal to u square plus 2as. Third equation, s equal to ut plus half at square. Distance traveled, initial velocity, time, acceleration, time. Displacement is a vector, initial velocity is a vector, acceleration is a vector. Now look at this second equation. V square, v is a vector but v square is a scalar, so it is dot product of v and v. U square is dot product of u and u, plus since these two are scalars, this must be a scalar quantity, so it is dot product of acceleration and displacement. So these three are the vector forms of equations of motion. And in equations of motion, this condition is true. It is true only for uniform acceleration. Okay. Now, these are the variables: v, s, t. Final velocity, displacement, time. In any problem, if we see final velocity and time, then we can apply v equal to u plus at. S and t are the variables, then s equal to ut plus half at square. Vs are the variables, then v square equal to u square plus 2as. Of course, if Vs are variables, we can use this equation, after that use this equation to get the displacement, or else directly use v square equal to u square plus 2as to get the answer. Okay. In these three equations, time is the variable, independent variable, velocity is dependent variable. Initial velocity and acceleration are constants. Since it is for uniform acceleration, acceleration remains constant throughout. Initial velocity means this initial velocity is not a variable, this is a constant. Therefore, velocity as a function of time, velocity as a function of displacement, displacement as a function of time. So these three are called equations of motion. Along with those three equations, one more. Distance traveled in nth second of accelerated motion. Understand, distance traveled in nth second of accelerated motion. This is distance traveled in 10 seconds. Yes, 10. This is distance traveled in 9 seconds. Yes, 9. So this is the distance traveled in 10th second. I can write yes, 10th. If a body is moving uniformly, with uniform acceleration, with initial velocity u and acceleration a, then this is the distance traveled in 10 seconds, distance traveled in 9 seconds, then this is the distance traveled in 10 seconds. So this is obtained by s 10 minus s 9, distance traveled in 10 seconds minus distance traveled in 9 seconds equal to distance traveled in 10th second. Now with general notation. Distance traveled in n seconds, distance traveled in n minus 1 second. Therefore this is the distance traveled in nth second, yes, nth, which is equal to u plus a by 2 into 2n minus 1. So this is the equation for distance traveled in nth second. Now this is distance traveled in n seconds. Distance traveled in n seconds means s n. This is actually time. So I can use s equal to ut plus half at square. Okay. Now this is distance traveled in n seconds, u n plus half a n square. S n minus 1 is distance traveled in n minus 1 seconds, u into n minus 1 plus half a into n minus 1 square. These two equations are from this equation. Now difference of these two equations gives s nth. So s nth equal to distance traveled in nth second equal to u plus a by 2 into 2n minus 1. Okay. Now observe the beauty. S nth is meter, distance traveled in n seconds. U is initial velocity, meter per second. A is acceleration, meter per second square. N is time, second. 1 is time, 1 is 1, constant. So actually this doesn't satisfy the principle of homogeneity of dimensions, means dimensionally incorrect. Actually the equation is not dimensionally incorrect. We have to observe these numbers, u into 1, n2 into n into 1 minus 1 square, because distance traveled in n seconds is un plus half a n square. Distance traveled in n minus 1 seconds is u into n minus 1. This 1, unit of 1 is second. Excuse me. Plus half a n minus 1 square. Again unit of 1 is second. Therefore, now according to this equation, corrected equation with 1, 1 and 1 square, you take the difference, you will get this equation. Okay. S nth is meter. Initial velocity is meter per second. Unit of 1 is time, second, plus acceleration meter per second square. 1 n is second, 1 is second, therefore second square minus, it should be 1 square. A minus b whole square, from this we get 1 square, so second square. Second square minus second square is second square, meter per second square, plus this is second per second, get cancels, meter, meter plus per second square get cancels, meter. Meter plus meter is one more meter, means length plus length is one more length. This equation is dimensionally correct. Distance traveled in nth second. Okay. Next, one more equation. Acceleration of a body in terms of distances traveled in consecutive equal intervals of time. Understand the meaning. Acceleration of a body in terms of distances traveled in consecutive equal intervals of time. Body is accelerated with initial velocity u. This is distance traveled in t seconds. This is s2, distance traveled in next t seconds. Therefore, in this case, acceleration is given by s2 minus s1 by t square. Now, we can't use this equation for this case. S1 is distance traveled in t seconds, S2 is distance traveled in t prime seconds, means 4 meter is distance traveled in 2 seconds, 10 meter is distance traveled in 3 seconds. Now these intervals are not equal, so we can't use this equation. Look at this equation, this case, 4 meter is distance traveled in 2 seconds, 10 meter is distance traveled in next 2 seconds. Now these two are two consecutive equal intervals. These two are distances traveled. Therefore acceleration is s2 minus s1 by t square, 10 minus 4 by 2 square. This is 6 by 4, 1.5 meter per second square. So instead of 3-4 steps, we can use this to solve the problem. Okay. Now this is distance traveled in s1. S1 is distance traveled in t seconds. S2 is distance traveled in next t seconds. So acceleration is s2 minus s1 by t square. Here s2 is greater than s1, therefore acceleration is with positive sign. This is acceleration. S1 is distance traveled in t seconds. S2 is distance traveled in next t seconds. Here s1 is greater than s2. Now we get acceleration s2 minus s1 by t square. This s2 is smaller than s1, therefore we get negative sign. This is acceleration, that is why distance increases with time, whereas here distances decrease. This is retardation. Last topic in this chapter, relative velocity. Relative velocity. Velocity of a body with respect to some other reference is called relative velocity. Okay. Now understand this relative velocity through different examples. First example, road, vehicle A moving with velocity VA, vehicle B moving with velocity VB. Velocity of A with respect to B denoted by VAB. Understand? Velocity of A with respect to B. Suppose we are in B and we are observing velocity of A, then this relative velocity is defined as VA minus VB. Similarly, velocity of B with respect to A denoted by V, velocity of B with respect to A, equal to VB minus VA. VB minus VA. Velocity of B with respect to A. Okay. This is how relative velocity is defined. Now, in relative velocity, first example. This vehicle A is moving with velocity 10 meter per second. Vehicle B is moving with velocity 20 meter per second. I want velocity of A with respect to B. Okay. So I can denote this by VAB. Velocity of A with respect to B. B is our vehicle. We are sitting in this vehicle. We are going faster. Going in faster and we are observing this A means this appears to be going slow with respect to B because we are going faster in B. Okay. We are going ahead means this appears to be going back. It is VA minus VB, that is VA is 10, VB is 20, answer is minus 10 meter per second. Magnitude of relative velocity is 10, meaning of negative sign. Since velocity is a vector quantity, in Cartesian sign convention, this is plus and minus. Velocities along positive x-axis are taken with positive, velocities along negative x-axis are taken with negative sign. Okay. Now we are going faster. We are observing A. A appears to be going back. A appears to be going back means backward means it is with negative sign. Okay. Now velocity of B with respect to A. Velocity of B with respect to A is VBA. Then it is VB minus VA equal to VB is 20, VA is 10, so magnitude is 10 with positive sign. Unit is meter per second. Velocity of B with respect to A means A is our vehicle. We are sitting in A. We are going slowly, but B is going faster. If it is going faster, B appears to be going in the forward direction with 10 meter per second. Forward direction is with positive sign, therefore this is also with positive sign. Okay, now you are clear with these signs, and also magnitudes. Now second case, this is A. Velocity of A equal to 10 meter per second. Another vehicle is approaching this first vehicle with speed 20 meter per second. This is B, therefore this is velocity of B. Since velocity is a vector quantity, in Cartesian sign convention this is taken with minus sign. Now I want velocity of A with respect to B, denoted by VAB. B is our vehicle, VA minus VB. VA is 10, VB is minus 20, so minus of this minus is this minus 20, so it is 30 meter per second. So if vehicles are traveling in opposite directions, with respect to the other vehicle, one vehicle appears to be going much faster, that is why this 30. Now meaning of positive sign, velocity of BA with respect to B means we are going in B. We are going in B in this direction. For us, A appears to be going along the positive x direction. That is why plus. Now, velocity of B with respect to A. Velocity of B with respect to A equal to VB minus VA equal to VB is minus 20. Minus velocity of A is 10, so it is minus 30 meter per second. Again magnitude is same but negative sign. It is velocity of B with respect to A. Velocity of B with respect to A means we are going in A. And when we observe B, B appears to be going back. Going back means along negative x-axis. That is why this negative sign. Okay, please go through different cases in relative velocity and try to understand. Wherever required, pause the video, note down and try to understand. Okay, now another beautiful concept. This is the road now. Vehicle A is going with 20 meter per second. Vehicle B is also going with 20 meter per second. Okay, I want what is the velocity of A with respect to B. Next, what is the velocity of B with respect to A. In both the cases, magnitude of relative velocity should be 20 root 2 meter per second. See, if you have understood the concept properly, then it is very easy to get the answer. 20 meter per second, I want velocity of A with respect to B and velocity of B with respect to A. Okay, and magnitude of these two relative velocities is 20 root 2 meter per second. You have to think why it is 20 root 2 and what is the direction of this relative velocity in these two cases. In this case one direction, in this case some other direction. Okay, this is to think. Good luck.